Welcome back. Now we're going to continue our unpacking, our investigation into the electromagnetic spectrum by having a look at some different wavelength and different frequency types of electromagnetic radiation, and then having a look at what they are used to achieve. So let's take a look. So we're looking at the electromagnetic spectrum, and we've said that this spectrum is made up of a range of wavelengths. So if we look at only the electromagnetic spectrum's worth of waves that have long wavelengths, we get these three groups. We get the radio waves, which we already spoke about as being responsible for transmitting your favorite song across the country. But perhaps you also know that microwaves represent long wavelength electromagnetic waves. I'm sure you've heard or used a microwave before, and maybe this is surprising because often we have to be quite careful with the microwave. But later, when we have a little bit more information, we'll be able to see how the microwave is in fact quite safe. Long wavelength radiation also includes infrared radiation, which, as we said earlier, is most commonly associated with our idea of heat. When you feel something as being warm or hot, that is infrared radiation being transferred to your body. So what are some of the uses of all of this electromagnetic radiation? What's the significance of the electromagnetic radiation having such a long wavelength? Is it something that's important to us? Absolutely. Let's have a look. So what do we use radio and microwaves for? Well, we've already said it, but let's re-emphasize it, that radio waves are used for broadcasting messages via the radio, mobile phones, and television. Radio waves are also used to receive messages from space. Did you know that we use radio waves to communicate with satellites and spaceships far out in space? Can you think of a reason why we would use radio waves? Maybe it has something to do with how fast they travel through a vacuum. Let's have a look. Some of the uses of microwaves are well known to us. Microwaves are commonly used in our households for cooking or heating food. How do they do this? They activate vibrations and rotations in the water molecules of our food. This right here is part of the reason why a microwave is actually quite safe to use in your home. It's got a thick layer of material that prevents any microwaves from escaping the actual oven itself, but also these microwaves are very specifically tailored to only have frequencies and wavelengths that cause water molecules to vibrate, and that vibration is what heats our food. So what about the other types of electromagnetic radiation out there? What are some of the uses of infrared? Well, infrared is quite common in our modern lives at the moment, but it is already commonly used in the medical treatment of sore muscles, scanning, or the use or forming of images in low light conditions, as well as the analysis of chemicals, something that many electromagnetic waves are used to do in a field of science called spectroscopy. Let's just look a little bit more here at our scanning/low light. If you take a look on the right-hand side of the screen, you can see an image being formed of someone using infrared. This means that the infrared radiation being released from their face and body is being captured by an infrared sensitive camera lens and being converted into those colors that you can see. Have you ever seen an infrared image like this before? Have you ever thought about which parts of your face might be warmer than others? Pretty interesting, hey? Now we've looked at the long wavelengths, but what about if the wavelengths get a little bit shorter? What if we have a look at the visible light that's so important to us? We know that visible light can sort of be imagined as all of the colors of the rainbow. Our new understanding allows us to know that in fact all of these colors come from different frequencies. So what are their uses? We use visible light quite often in fiber optics. Maybe you've heard of adverts for fiber internet coming to your neighborhood. This is the fiber optics that internet will be using, and part of the reason that it's so good is that it can transmit information at that speed of light c we were talking about before. Another use of visible light is lasers. Now lasers are used in everything from the very simple, like pointing at a board during a lecture, to the very complex, like sending signals through space or over long distances, or in the late evening when it's very dark. Obviously, one of the most important uses of visible light is that of making video. Obviously, video is very important to us in our modern lives. I highly doubt if you own a cell phone that you haven't already seen a video on it today. But now, what about those shorter wavelength electromagnetic waves? Those ones that we've been describing as perhaps a bit more dangerous, with a bit more energy. Let's have a look. Our short wavelength electromagnetic waves are fit into three broad categories. The first category is ultraviolet radiation. And if that sounds familiar, don't be surprised, because it's often abbreviated to UV radiation. And if you've heard UV before, when maybe in a sunscreen ad, this is exactly the radiation they are talking about. They are referring to the ultraviolet radiation that is released by the sun that can be quite dangerous to us if we are overexposed to it. The next category of short wavelength electromagnetic waves is the X-rays. These are those ones that are used by medical doctors to see inside the body and have a look to see if any of our organs or bones are damaged and in need of repair. These X-rays can also be used, because they are so high energy, to target cancer cells and kill them in a process known as radiotherapy. The last category of short wavelength electromagnetic waves is our gamma rays. These guys have the highest frequency and the shortest wavelength and carry the largest amount of energy, and this can make them quite dangerous. Did you realize that when you were putting on sunscreen to go outside on the weekend, you were protecting yourself from radiation? Did you realize that X-rays were also a type of radiation and that we've been using for many years to look inside the human body? Well, what other uses are there of these types of radiation? Let's have a look. So what are some of the uses of UV? UV radiation tends to have quite a low energy, and this makes it quite safe to work with. For this reason, we often use it in the analysis of chemical compounds. Certain compounds will only glow under UV light, or will only break down under UV light. Another more commercial use is tanning, where we lie in a tanning bed and expose ourselves to UV light to increase the amount of melanin in our skin and make ourselves appear more tanned. We also use UV light in the sanitation process. If you've drank water from a municipal tap or from a bottle of water lately, that water was most likely at some point in its lifetime sanitized using UV radiation. Did you realize there were so many uses for UV radiation? Did you realize that it was even being used to sterilize your drinking water? Pretty cool, eh? So what about those other types we were looking at? Well, as we said already, there are many uses for X-rays and gamma rays, but most of these uses lie in medical treatments and radiation therapy, where we use the high energy of the X-rays or the gamma rays to destroy cells that may be dangerous to the body, or alternatively, we use the X-rays to look inside us, like you can see in the image on the right, to have a look at the internal structure of the body and see if there's anything wrong.